Hey everyone, and welcome back. In today's video, implementing linear algebra operations in Python. Today we will cover all these topics in our video. So, today we are taking a step up in our coding journey. We are going to tackle a topic that sounds a bit intimidating, linear algebra. But don't worry, we are going to break it down. We will learn how to use Python and specifically our friend NumPy to perform these powerful mathematical operations. Get ready to turn your code into a serious number crunching machine. So, what is exactly the linear algebra? In simple terms, it is the math of the vectors and the matrix. These are just fancy way to organize and work with the numbers. It's the engine that powers so many things we use every day like the recommendation system on Netflix, the graphics in video games, and those core of the machine learning models. It's all about solving problems and treating numbers as a group rather than one at a time. Moving forward, vectors in Python. Let's start with the basics. Vectors. In linear algebra, a vector is just a one-dimensional array. Think of it as a single row or a column number. Thanks to NumPy, creating one is a super easy. We just write an np.array and put our numbers inside the brackets. You can perform simple maths on the vector, like adding a number to every single item. This simple building block is the foundation of everything else we will do. Now I will show you how to create vector in Python code for this linear algebra. Simply start Anaconda, navigate there. Here's the Anaconda navigator. Simply launch the Jupyter notebook. I will create a new file here. Okay. Here, simply, first we have to import the NumPy. Just spelling mistake for a second. And sorry for this. Uh, Here, in this, we simply imported our NumPy library, and in this, we have imported the LI and ALG. It stands for linear and ALG for algebra, linear algebra. And for creating a simple vector, you just have to start with, I will name as A and P dot. These are all the components or the elements of the vector. Just run this and here print A. Here you can see a simple array. It's the basic method, or we call it as it's the simple way to represent an vector in Python using the Python codes. Next up, our matrix. A matrix is a two-dimensional array, a grid of numbers with both rows and columns. They are perfect for representing things like images, where each pixel has a color value, or a table of data. To create a matrix in NumPy, we use nested list inside a NumPy array function. We can then easily access any number in the matrix by telling Python its row and column number, just like finding a cell in a spreadsheet. I will show you how to create a matrix using Python code. Now, for the matrix, we simply have to create a two-dimensional array for the matrix. We will do this. So now for the matrix, we simply have to create a 2D array. Here you can see I have created a 2D array with the element in the first array, first row as 10, 20, 30, and 40, and in second row, here's the 80, 30, 20, and 10. Here you can see the matrix. It's simply a 2D array, but in linear algebra, we use this 2D array as our matrix. After understanding what is matrices, let's move forward. Now it's time for some basic operations. One of the simplest and most common operation is addition or subtraction. The rule is simple. The vectors or the matrix must be exactly of same size. NumPy automatically does the calculation for us, adding or subtracting each element in the first array with its corresponding elements in the second. This is so much faster and more efficient than trying to do it with a regular Python loop. Let's see how it is work. We launch NumPy notebook, Jupyter notebook here. Now it's time for basic operations. I will show you some of the basic operations here. First, we start with importing the NumPy and the linear algebra modules. Simply run this. Uh, just typing error. NumPy. Now we will create two matrices here. Just naming it N1. For your easy understanding, I will create two matrices like this. This is our first matrix. And now for second. Now this is our these are our matrices one and this is second. Simply we will print both the matrices and here print N1 print N2. Just I will make it as this way. Here I think you can see both the matrices. The matrix number one, two, two, matrix one, and matrix two. So now we will do different operations on this. First, add addition. So addition in this column only. Matrix addition. You don't have to write a very large code or calculate each column one by one. You simply have to write a well, sorry, we have name as n1 plus n2 And you can see here the NumPy automatically generated the added or the perform the addition in this matrix. You can see if we add this row to this row of first matrix to row of first or second matrix, here you can see simply 1 plus 9 equals to 10, 2 plus 7 equals to 9, 3 plus 8 equals to 11, and so on. Similarly, the NumPy added all the elements to its corresponding element of another or the other matrix. If we simply change this number like 20 and 5, just putting random values here, now you can see the matrix has changed and the addition has also changed. This is the simple way or the basic operation of the addition performed in linear algebra. For multiplication, I will show you two different methods. First, the matrix multiplication. In this, just this is first matrix. You have to use the symbol of at the rate and the second matrix. Simple run this, and you can see here it's the matrix multiplication. The at the rate symbol is used for this multiplication here. And similarly, I will copy this whole line just here. And now element, I will show you element wise multiplication. Element wise multiplication. It's simple using the star symbol. You can see here it's the element wise multiplication. Both are different. Or we can check here. If we simply multiply 1 to 6, the first row of matrix first and the first row of matrix second. Here it is 1 multiplied by 6 equals to 6 and 2, 2, then 4. This is the element wise multiplication. Now I will show you some of the matrix properties. Matrix, matrix properties. First, transpose. Transpose. Okay. First, the transpose. We write the print and the transpose matrix. Here, you simply have to write N1 as the first matrix dot E. This is used for the transpose Ulan ज़्यादा ये मैं क्यों लिखा हूँ बस रन करके देखो अच्छा चलते गया. The first property is transpose, and you simply have to run these function on your system. Just n1 dot t. N1 is your first matrix, and dot this is t is used for transposing that matrix. You can check here. Okay, I will print n1 here also. Just wait. N1. Now you can check here. It got transposed. 1, 5, and 2. Here this is 1 and 5 and 2. Column changed into row. Each column 266 here, 266, 377, 377. And for now, I will show you the second property, diagonal elements. Simply, I will copy this, change according to each property. For diagonal elements, you have to run np dot as its pro function of numpy np dot dig diagonal elements, and now we have to write on which matrix we are going to use it. As we printed first matrix here, I will show you for the first one. Here you can see the type diagonal elements 1, 6, and 7. 1, 6, 7. If we change our matrix from here, diagonal elements will be 9 and 0 and 5. We change the diagonal elements to 5, 0, 9. Okay, we have to run each cell according to that. 5, 0, 0 and 9, and then we again run this cell, and you can see the diagonal elements are changed. Now the diagonal elements are 509. Oh, sorry, it's diagonal elements. Diagonal elements. And now for the third property, how to create a diagonal matrix. Creating diagonal matrix. Simply a variable diagonal matrix, and for this we have to first give the diagonal elements to a variable, and set as to this is now matrix. And here you can see the diagonal matrix as we have provided the diagonal elements as 2, 5, 6, and 8. This is 2, 5, 6, and 8. You can see here. This is our diagonal matrix. Only the diagonal elements are present and other all are as zero. Now it's time for some linear algebra operations. I will simply use linear algebra operations. First, we will start with determinant. Determinant for and two matrix. We will do for the second matrix this, and now we will use LA as you can see here the linear algebra module. We has imported this as LA, so we will use now the LA module here or this is the function for determinant and do run here. You can see here, this is the determinant for second matrix. I will print second matrix here. This is the determinant for the second matrix. This is the matrix and this is the determinant. You can also print the determinant for the first matrix. Here it is the here we calculated the determinant for the first matrix. Now how to make inverse of a matrix? Inverse. Simply inverse. Inverse of n1. We'll do this one and two one. Simply into underscore inv. This is the method for la.inv and then for L2 matrix, second matrix. Here you can see the inverse of the second matrix. Similarly, you can do for the first matrix also. And now it's time for some of the very important elements of linear algebra, the eigenvalues and the eigenvectors. Eigenvalues and eigenvectors. I will show you how to calculate both of them. Simply you have to type eigenvalues IG, and we will calculate for 7 matrix. Then values this is variable here and for eigenvectors this simply run this code and you can see here these are the eigenvalues for second matrix and this is the eigenvectors for the second matrix. You can see how fast and how precise the NumPy is as these both calculations are very large and time taking, but in a click of a second it shows both of the equations. First we will create a function matrix without adding then second count. And now we will create constants without adding and 5 and 6 single line and for solving the linear equation solution equals to root of. To solve the linear equation, we have to use solve function of linear algebra module where the first element is coefficient and for the second is constant. And now for this, simply print. Now here you can see we get two elements. This is the value of x and this is the value of y. This is the solution of these linear equations. And if we have to change the values, simply if we change the values like 5, 50, 70, we also have to change the values here. And this is 3, 8, 50, and 70. If we run this and then this, you can see here the values for x and y are changed as we change the linear equations. So let's move forward in our presentation. The dot product. Now for a really important one, the dot product. This is a special type of multiplication for vectors. It's not just a multiplying elements by elements. The result of a dot product is a single number. This operation is a fundamental in many fields, especially in machine learning, where it's used to calculate things like the similarity between two vectors. NumPy makes this complex calculation incredibly simple with the function numpy.function. I will show you how to perform dot product using numpy functions. Simply run the Jupyter notebook and oh, we have already used the Jupyter notebook here. For this uh, dot product, we again import numpy as empty. Now we will create two different vectors x np.array and then elements 2, 4, 6, and 8 and for y dot array y. These are both vectors and we will perform our dot product on these two. We run this and then np dot. This is for the NumPy module and this is the formula or the function to solve the dot product of two vectors. And first vector is x and second is y. Simply run this. You can see here the dot product of our vectors is 100. You can also change the position. Earlier we have used x and y. Now we will check for y and x and check what's the dot product of this. It's also 100. It's not a position dependent variable or the function. If we change the position from x to y or y to x, it remains the same. Now, I will show you how to calculate dot product of a matrix and a vector. As we have created vector here, so for the matrix we have to create a new matrix. Set np dot array. One, two, three, and four. One more, 5, 6, 7, 8. Here we have created a matrix. Now we will do the dot product for the matrix and vector. Simply np dot dot and one is a matrix Z and a vector. We will use first vector x and run. Here you can see. This is the dot product with the matrix and a vector. Here you can see two values as the dot product of each row is in each value. First, it calculated the dot product of 2, 4, 6, and 8, the vectors with the first row of the matrix 60, and then calculated the dot product of the vector and the second row of the matrix 140. You can similarly check for second vector and here y. Simply print, you can see 50 and 114. These are the dot product for matrix and vectors. Now I will show you how to transpose the matrix. As I okay, in starting I only show you how to inverse it. Now I will show you how to transpose. Transpose matrix. Yeah, here we have seen the transpose. If you want, I can show you. It's simply. I will show you one more method to transpose the matrix. Here, the transpose here, and the matrix is here. You can see the transpose of the matrix 1, 5, 2, 6, 3, 7, and 4, 8. I will show you one more method to transpose it. np.transpose just write the whole and matrix itself. Here you can see you can use simple the matrix name with dot t function, or you can use the transpose function as a wish, but both of them give you the same result 15263748 152637 and 48. You can see here, and this is our matrix on which we use transpose function. Now I will show you how to create a identity matrix. For identity matrix, simply type np.I. This is function for identity matrix, and the number of rows, total elements, how many diagonals we needed. We can start with 3, and you can see here 1, 2, and 3, 3 diagonals, and this is our identity matrix. If we change here, we change to 10, you can see here a 10 by 10 matrix and identity matrix. Here you can see like this you can create an identity matrix. And now I will show you the matrix multiplication. Simple. Already have shown you matrix multiplication here. this one, matrix multiplication. But I will show you one more method. Simply copy this or simply write matrix multiplication. Okay, then first we use matrix. First we inverse the matrix. Okay, inverse, yes. And now we will use the third matrix. The third inverse I will use z I as the variable for z inverse. Inverse into np dot okay, as we need a square matrix for inverse, that's why this is showing the error. We'll create a new matrix A equals to here 1 comma 2 brackets 3 comma 4. So we'll use here in and now right. Here's the transpose matrix. Now for the matrix multiplication. Earlier I have shown a method using the at the rate symbol. So simply you can use at the rate for the multiplication. You can see here this is the matrix we get after using the at the rate function. You can also use dot product np dot and a comma a inverse. You can see both are same. Both matrices are same here. As we use these values, that's why the values are a bit much larger. And now I will show you how to trace a matrix or how to calculate a trace of a matrix. Simply, we will use this matrix only, the A matrix, this matrix, and we have to dot np dot trace and here you in. You can see here the trace is 5. This shows the trace of the matrix and the trace function is the last function for today. I think this is enough for linear algebra functionalities. Let's move forward in our presentation. Matrix multiplication. This is a more complex operation with a key rule. The number of columns in your first matrix must match the number of rows in your second matrix, just like a dot product. NumPy handles all of these for you. You simply use np dot dot. To do all this heavy lifting, these operations are essential for things like rotating 3D objects in a computer graphics or transforming data in a machine learning. We have already seen how the matrix multiplication works. So let's move forward. Key takeaways. So to recap what we have learned, NumPy is go-to tool for all linear algebra operations. Vectors are one-dimensional arrays and matrices are two-dimensional grids or numbers. Basic operations like addition are easy and automated, and special functions like np.dot handle more complex but incredibly powerful operations. You have now a solid understanding of the basic concept. Ready to practice? The best way to solidify your understanding is to get your hands dirty. Open up your code editor and try creating your own vector and matrix. Experiment with addition them together and trying using the dot product function. And the world of data science and machine learning is built on these fundamental concepts. You you are now well on your own way to mastering them. Happy coding. Thank you.